Okay, so we're going to have a look at another question from the 2022 HSC Standard 2 Maths paper. So we're told, this question in fact is question 23. A teacher surveyed the students in her Year 8 class to investigate the relationship between the average number of hours of phone use per day and the average number of hours of sleep. The results are shown in the following scatterplot. The data for two new students, Alinta and Birani, are shown in the table below. Plot the results on the scatterplot. So I'll draw a little diagram here representing the scatterplot. So we go from 0 to 10, and then on this axis we go from 4 up to 11. So we are told Alinta has 4 hours of phone use per day. Phone is on the x-axis and sleep is on the y-axis. So Alinta has 4 hours of phone, 8 hours of sleep. So 4 is about here, 8 is about here. So 4, 8, this is Alinta. And Birani has 0 hours of phone use, 10.5 hours of sleep. So she actually falls directly on the axis, on the sleep axis, about here. So plot the results on the scatterplot. Done. So this is the answer to part A. By first fitting the line of best fit by eye on the scatterplot, estimate the average number of hours of sleep per day for a student who uses the phone for an average of 2 hours per day. Okay, so we can look at our scatterplot here. The points sort of are roughly similar to what we've already got plotted. So we have something that looks roughly like this if we loosely transcribe these points onto our graph. If we want to do a line of best fit by eye, it looks something like this. So we need a line which roughly describes, we need an equation which roughly describes this line. Well, it seems to pass through the point 8, 4, and it seems to pass through the point 0, 10.5. So we have a little triangle like this, goes from 0 to 4, so its base is 4. This is a slope triangle. The height goes from 8 to 10.5, so its height is 2.5. So the rise over the run slope is 5 on 8. So we did this using the 2 points which we just plotted. You could use other points. There's a bunch of different variations of graphs that you could get here. And it's negative because it's going down. Also passes through the y-intercept at 10.5. So B is 10.5. So this tells us that in part B, our line of best fit, y is equal to about minus 5/8 times x plus 10.5. So estimate the number of hours of sleep for a student who uses the phone 2 hours a day. The phone is x in this case, because phone is on the x-axis. So if x is equal to 2, y is equal to minus 5 on 8 times 2 plus 10.5. So these cancel. This gives us minus 5 on 4 plus 10.5. Minus 5 on 4 is minus 1.25 plus 10.5. So 10.5 minus 1.25, that's about 9.25. So therefore y is about 9.25. So the number of hours you should expect is roughly 9.25 hours. And you could get 9, you could get 10, you could get 9.5, you could get 8.75, something like that. If you use different values, if you fit the line of best fit slightly differently, you'll get variations. This is just an estimate. So in this case, we're just doing a line of best fit by eye, so that's a very crude calculation to get the line. Then we're plugging x equals 2 into that. So this could vary by quite a bit. Could vary by, plus or minus a half on both the slope and the y-intercept, and then by plus or minus 1 or 2 on the actual answer. And the range of answers acceptable will be something along the lines of 8 to 10, or something within those range, something within that range. So this is worth 4 marks. So you'll get 1 mark for graphing one of the girls. You'll get another mark for graphing the other girl. That's the first 2 marks, very straightforward. Part B, you'll get a mark for attempting to construct a line of best fit using the given data. And then you get another mark for correctly estimating a y value based on that line of best fit. And again, that will be within tolerance. So the markers will accept particular lines of best fit. If your line of best fit is completely wrong, you will not get the answer mark. You may get some working mark. But this question, 4 marks, it's reasonably straightforward if you use your line of best fit and you try and pick a fairly good line of best fit.